All right, take a look at the matrix up here. If you're having trouble locating points in the first quadrant, you're trouble on the test. Make sure you know how to plot points. If you know how to plot any point on the coordinate plane, you're doing well. And then we're going to be actually doing this kind of stuff. So we're locating points and polygons in the coordinate plane. We're actually doing the domain and range, and then we're exhibiting the knowledge of the slope. So,
ironic, it says fun.
is it fun?
No.
No, domain and range is not all that fun. It's a little abstract of a concept.
Yeah.
But we'll keep talking about it. It takes a while to get down. All right, looking at this. So when you graph an equation, every equation is actually a line. If you see an ordered pair, it's just a point. So make sure you understand that idea. If it's an equation, it's a line. If it's an ordered pair, it's a point. So because I have an equation here, you know there's lots of points, and it's a line. How do you graph an equation? Now, this is something you should have tried last year.
I don't remember.
Don't remember graphing lines?
I do.
Oh, I remember graphing.
That's what we're doing. How did you remember anything about it? What comes to mind?
Lines.
Okay, and how did you make that line?
By drawing it with a pencil.
Lovely.
Nice.
Any more detail?
No.
Ooh. Then we don't know how to graph a line yet. It's got to be a line that satisfies that equation.
I think we need a refresher.
Okay. Well, how many points are on a line?
2.
Technically.
No.
A lot.
How many is a lot?
Infinite.
Infinite points on a line. Okay? You only need 2 to graph it.
I was thinking line segment.
Yes. A line segment, you only need 2. But even in a line segment, there are infinite points in a line segment.
Sure.
Because there's so many ones that are in between, and in between that, and in between that, and goes on forever. With me?
Oh, yeah.
All right. So we need points to follow. How do I find a point? If I have an equation, can I figure out a point that will satisfy the equation?
Yeah.
How would you do that? You plug in a number, right? Let's try one. 1. If I plug in a 1, I'm plugging a 1 into here, right? So what I'm actually going to do is I'm going to actually put in 2 times the 1 that I chose minus the 7. And then I evaluate that. And what is 2 times 1 minus 7?
-5.
It is -5. So this is how it worked. Oops, I did it. Let's do that. All right, so I have an ordered pair. What's the ordered pair? 1, -5. Where do you graph 1, -5? Now we're back all the way to...
Man, it doesn't have the numbers on.
Go over 1 and down 5.
So when you say go over to the right over or to the
Yeah.
left over?
Right.
Over to the right one and then down -5? 1, 1, 2, 3, 4, 5. Right there? Okay. Well, I need a bunch of them because the line has to go all the way across the plane. So let's do another one.
2.
2. All right, let's do 2. 2 times 2 minus 7.
-3.
It is a -3. So it's 4 minus 7, and 4 minus 7 is -3. So we have 2 -3s. So 2, then -3. Let's choose another one.
3.
3. 2 times 3 minus 7.
-1.
-1. 3, -1. You guys discovering a pattern yet?
It's going down by 2.
It's going down by 2. Not quite.
Going up by 2.
It's going up by 2.
Oh, yeah.
You see that?
Yeah.
By 2 and over by 1.
Yeah, so every time you step 1 to the right, you're going how many up or down?
2 up.
You're
1.
going 2 up, right? So do we need to keep plugging in points?
No.
No, can we figure this out? That's
Yeah.
what I want you guys to be able to do. You start off with about 3 or 4 of them, and then keep the pattern. The pattern is every time you step 1 to the right, you go up 2. So up 1 and then right 2. Up 1, up 2. Up 1, or over the right 1, up 2. The right 1. Get the idea? And can you continue the pattern in both directions?
So you go over.
So then you go down, 2 into the right one, down 2 in the right one. So that's what you're going to do. You're going to make those points, and then you draw a line through them, because it has to go all the way across. And if you're really great at drawing lines, then there you go. That's what the points are do to help you out. Otherwise, you can use a ruler if you want.
Yeah, my line's kind of crooked.
You should be.
Get the basic idea of this.
Mm-hmm.
Okay? This is a really tedious way of graphing lines.
Forget mine came out wrong.
I'll be able to show you, just by looking at it, you could do that in about 5 seconds. That's where we're going with this. But we need this basic stuff down. Because the shortcut, or the method I'm going to show you, is like a super shortcut. And it takes a while to understand. So, but it's a basic concept for the rest of the math. All right? What you guys just started to look at when you said, hey, I see that it goes up 2 every time I step to 1 to the right. That is the idea of slope. It's a major concept that you need to have down. This is just the beginning of it, okay? All right, for the next one to the right, how do I do the same thing I did before?
And I get 2 variables.
Put in 1 for X and 1 for Y.
But we don't know that for sure.
Get Y by itself first.
You have to. Now, why do you think we had getting Y by itself the previous lesson?
So we can do
For
this.
this. And if you didn't do that, well then you're stuck here. Until you get this down, you won't be able to do these problems. So you need to know how to get Y by itself. And does anyone know the method?
Onion.
Great. If you do the onion technique, what would you do?
Yeah.
Circle. Now, which one are we trying to get?
Well, we're trying to get
We
Y
want to
by
get Y by itself. Now, it's been always X because we always had one variable.
Yeah.
Now that we have 2 variables, the only one that we want to worry about right now is the Y. So we do it this way.
Wait.
All right. So now that I've made it, what does it tell me to do?
Subtract 6X.
Subtract 6X. And then? Anyone else?
Divide
I mean,
by
yeah.
3.
Divide by 3. And this is what it would look like. As you divide by 3, you go all the way across. That whole, the whole side gets divided by 3.
Plus 4 equals
Well, it's not 1/3. Nope. So remember this idea of this pretzel technique. Take a look at that. It's 18 divided by 3.
6.
That's 6. And then it's a -6 divided by a 3.
2X.
2 X.
-2.
It's close.
Yeah. So now I can start plugging and chugging. If you didn't rewrite it, you would have to rewrite it every time you plug in something for X and try to find Y. You'd have to rewrite it every time. That would suck. So rewrite it once, and then you don't have to rewrite it anymore. All right? And besides, the super shortcut says you want to get it in this form anyway, so we need to make sure we know how to rewrite equations to get Y by itself. All right, let's choose some numbers. Let's try different numbers. Instead of 1, 2, and 3,
-4.
8.
all right? We'll try a -4. Always try a 0. 0 is like the easiest one to do. You should always throw a 0 in there. And then what's a 5? All right, we'll try those. So a -4. I'm gonna put this in there. So 6 minus 2 times -4.
6 plus 8.
It is a 6 plus 8. Those 2 negatives cancel because they're multiplying.
14.
And then it's a 14. Now sometimes this is going to happen. So I got to graph -4, 14. How long is my graph? How high and low does it go? It only goes to 10, so you're going to have to estimate if you do this. So sometimes this will happen. So you're at -4, 1, 2, 3, 4, and then this is 10, and then you kind of 1, 2, 3, you kind of estimate it's about up there. Sometimes that'll happen. Don't worry, I'm not going to mark you wrong if you don't get exactly 14 up.
How many do we go over then?
Well, in this case
So
now,
-4, right?
Yeah, we chose a negative 4,
Yeah.
so I gotta go 1, 2, 3, 4 over, and then 14 up. If we plug in the 0, what's the answer?
6.
Yeah, it's 6. Notice that when you multiply by a 0, that term goes away. That's why 0 is always a lovely one to try. That's probably the easiest one to ever do. Throw in a 0 in there. So 0, 6. 1, 2, 3, 4, 5, 6. Now remember, you guys had some trouble plotting a 0, 6 or 6, 0, so make sure you know if it's the x or y axis. Those get confused a lot. And if we throw in a 5, it's the other way around. 6 minus 10. Yeah, it makes a difference because it's a subtraction. It definitely makes a difference. And what's that?
Negative 4.
Negative 4. So then you have a 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4 down. Now, can you figure out the pattern here?
Yep.
What is it?
Nope.
Harder, isn't it? So,
in order.
what would it be the best method when you're trying to choose points to figure out a pattern?
Negative 2, negative 1, 0.
Yeah, you want to do consecutive ones, right? So that's I wanted you guys to see that. If you do consecutive ones, it makes it easier to figure out the pattern and continue the pattern. If you choose just random ones, it's a little harder, right?
I don't even think those line up.
So, well, then now you need a ruler. All right? Or you could do something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I went 1, 2, 3, 4, 5. So it looks like I went up 10 and over 5. Can I reduce 10 over 5?
Yep.
Yeah.
To what? 2 over 1, right? Now let's say I do 2 then 1, 2 then 1, 2 then 1, 2 then 1. Got it. That's also slope. How much it rises and how much it runs is slope. And if you make it into a fraction and reduce it, you got it. It makes it much easier. Otherwise, you just use a ruler. Okay? So then you connect your dots. We see it goes over 1 and then down 2. So it does this kind of thing. Bless you. Oh. All right, questions on this?
Nope.
All right, guess what I want you to try to do?
Back.
Try the next two. You got an example to look at. So based on your example to look at, try a few of them. And if you pick a pattern, it's much easier. You can do consecutive, or you can do by 2s or by 3s or something. But if you do just 2 random ones, it's harder to figure it out. So you can be systematic with this, and it's much easier. So try the next 2, try to graph them. Obviously, you can see this one needs to be rewritten. So when you get to this one, ask one of us if you've written it correctly before you start graphing, because I don't want you to graph it and then you did it the wrong way and you got to redo the whole thing. So when you go do the next one, go ahead, when you rewrite it, let one of us know and we'll double check that you did it right. And then try the next ones. Okay? I'll leave this up here as an example to look at. All right, so this is screwed up, right? So we do what to try to write this in function form?
Yeah,
Okay, y by itself. So how do we start doing that?
Onion.
Onion technique on the y this time, not the x. We have been doing x because that's our only variable. Add a 3x. Add a 3x. We want that actual term gone. So that's a little bit different than what we've been doing. Usually it's just a number. Now we're actually getting rid of the actual term. Yep, then we're going to divide by 4.
3x over 4 plus.
Can I flip those terms around like that?
Yeah.
I can. Yep. As long as you keep the negative with the 7, it's all good. All right. Now that we have this, when I was helping you guys yesterday, I was giving you guys a hint of what numbers to plug in. Because that's a 3/4, if you just plug in any old thing, you're going to be left with decimals, and that kind of sucks to plot. So I did recommend that you might want to try like a -4, a 0, and a 4. Do you guys remember why, if I told one of you guys, why you'd use a 4?
Because they cancel out.
Yeah, because there's a 4 in the denominator. When you multiply by 4, they cancel, and then you don't have a nice number instead of a fraction. So you can be really smart about it by picking certain points rather than any old points. The other thing I want you guys to understand is I'm still being systematic. I'm going by 4s rather than by 1s or by 2s. If I go by 4s, you can still sense the pattern. Just be consistent with what numbers you pick, and it's all good. So let's see what this looks like. I throw in my -4, and as you guys just said, because I'm multiplying and dividing by 4, those things cancel, but it leaves the negative. So I actually have a -3. And -3 and -7 give you a -10. And there is my -4, -10 point. So far, so good?
Okay, that works.
Thanks.
Very welcome.
Dude,
You have $1? I'll sell you chocolate. I have a business of chocolate.
No.
I'm sorry.
All right, if I plug in a 0, that's really easy. What did you guys start noticing? If you plug in a 0, what do you get for an answer like right away? Yeah, it's the constant. That term will go away because you plugged in a 0 and you're multiplying by that. So you'll just get a 7 right away, or a -7 in this case. There's 0 and -7. And then if I plug in a 4, those 4's cancel, then you have 3 minus 7, which is a -4. So at 4, 1, 2, 3, 4, 1, 2, 3, 4. And then after that, I guess you see a pattern, right? How do you go from one dot to the next and get back on the line again? What are you noticing you're doing?
Up 3 over something.
Up 3 and over 1, 2, 3, 4.
Yeah.
3 and 4. Do you notice anything about 3 and 4 in the equation?
there's a 3 and 4 in it.
Yeah.
There's nothing to do with
If you can start recognizing that right away, you've started to understand the idea of slope. And our last little idea here, exhibit knowledge of slope. That's really what we're doing. You start seeing this pattern, and then you're like, hey, it keeps rising 3 and running 4, and I'm back on the line again. And then you keep rising 3 and running 4. So you don't have to keep doing this anymore. You do a couple of them, you get what the pattern is, and you got the rest of the line. With me so far? All right, I was smart about what I picked over here, right? How could I be smart about what I want to pick for this one?
2.
Use 2's, right? You're saying 1, 2, and 3, that's fine. If you use 1, you're going to get a fraction, right? Did you plug in 1 and you got something with a 0.5 in it? And then you use 2 and you got a whole number, right?
Yeah.
Then you use 3 and you got something with 0.5 in it again, right? If you use like 2 and 4, you just get whole numbers. What I'm saying is, you don't, if you want to put 0.5, it's fine. But you can, you just use 2, multiples of 2, and you can get rid of that fraction every time. All right? So let's actually kind of do, let's use 0, 1, 2, and 4, just so you guys can see when the fraction is there and when it's not.
Just 2.
That's just 2. So here's my 0, 2. If I do this, it's 2 and a half. So the fraction doesn't quite disappear. You're adding a half onto it. So here is 1, and here's a 2 and a half sitting right there. If I put a 2 in there, that's 1. 1 plus 2 is 3. And if I go up to 4, half of 4 is 2. 2 plus 2 is 4. So we can start seeing this pattern. And it looks like you're going up 1 and running 2. Up 1, running 2. Up 1, running 2. Is there anything that has a 1 and a 2 in the equation? Okay, so you see where you almost can start seeing this pattern right away.
This is super duper sneaky thing.
It's the beginning of the super duper sneaky thing, yes. All right, make sense here? All right, then all I want to do is I want to show you a couple more graphs, and I'm going to give you guys the rest of the time to work on some of these graphing problems in class so I can help you guys out.